So this is from 5.3. Which problem was that, Sean?
It was 5.3, question 2.
Okay, perfect. So we can only be asked to find g prime of s. So we will differentiate the left-hand side and differentiate the right-hand side. I have to pay attention to two things. Number one, this has to be a number. It is. But it has to be a number, any number. The upper limit has to be a function or plane s. Or it could be tangent s. It's not. But it could be anything in terms of s. Plane s or a function of s. So now I can differentiate. This is the question. This is what we have to determine. So g prime of s will be, when I differentiate, I hope you can see this. Let me know if you can, if it's not, if I'm skewed. So when I differentiate an integral, this cancels out and this cancels out. And what happens is I replace t by s. So this is s minus s to the 6th, everything to the 7th, and I should write times this function prime. But there is no need, because this function prime is 1. It's like x. It's s. S prime is 1. That's all I need to do. This is from the Fundamental Theorem of Calculus Part 1 that really is teaching us that differentiation and integration are inverse operations. When I differentiate an integral, I get the function. When I integrate a derivative, I get a function. The function. So that was it. That's all I needed to do. Next question. Anything else you would like to work on? Do I get to pick then, or you want to look?
You can pick. I mean, I don't have anything specific, really, so.
Okay, so let's look at problem 6 from the same section then. Anyone would like me to work on their problem, or you want me to work on the problem I see?
Yours is fine.
Okay, so I have the integral from 2 minus 3x to 3 from u to the 3rd over 1 plus u squared du, and this is a function, of course, of x. So they are trying to trick us, and they are denoting it by y. Fine. It's the same thing. Use part 1 of the Fundamental Theorem of Calculus to find the derivative of the function. They cannot ask me to do anything else. But this is not already set up. This is set up. The lower limit must be a number, the upper limit whatever. So there is a property of the definite integral that allows us to swap the limits of integration, but what happens if we do that? So let me refresh your memory. The integral from a to b from f of x dx is the same with the opposite of the integral from b to a from f of x dx. So when we swap the limits of integration, the integral gets a minus in front. And now this is completely set up for differentiating. I can differentiate y, and I can differentiate this piece. So when we do that, but this was crucial, I have to have as the lower limit a number, any number. So then when we get y prime, we will differentiate this. And when I differentiate the integral sign and the du go away. So I have u to the third plus over 1 plus u squared. But now I have to replace u with this function. The negative stays. So the numerator is 2 minus 3x to the third. The denominator is 1 plus 2 minus 3x squared. And now, here there is no need because s prime was 1. It was the independent variable. But here this is a function. So I differentiate the outer, and I got rid of the integral. But now I have to differentiate the inner. And the inner function prime is negative 3. I will cancel these two and put the 3 in front, the symbols. Oops, no, this is 1. This is 2. So then y prime equals 3. 2 minus 3x to the third over 1 plus 2 minus 3x squared. I'm hoping that you're going to keep all these notes, and when you get to that problem, then you know what to do. So I'm trying to get you finish this faster, sooner than if you would just do it on your own.
So how did you know for that problem to do that kind of switching and putting the
Very
negative
good.
in front?
Very good. So let me refresh your memory on FTC, Fundamental Theorem of Calculus, Part 1. G of x is the integral from a to x from f of t dt. So if I don't have a number here, I cannot apply Fundamental Theorem of Calculus Part 1 and differentiate both sides and get this. So this is Fundamental Theorem of Calculus Part 1. So that's why I was saying the requirement, first requirement is that this is a number, any number, and this is whatever. If it's x, then I don't have to multiply by x prime because it's 1. If it's a function, then I will multiply by that function prime, whatever that is. So here,
So
go ahead. Sorry.
in the previous one, you knew to apply that because it was a function for the case of a.
Oh, yes. So I knew that this wasn't ready.
Okay.
I couldn't differentiate with the function here. I had to have a number here and the function at the upper limit, or just plain x. So that's why I had to swap. And this is a property that we discussed when we discussed those 11 properties of definite integrals. So if you go back to those 11 properties, one of them is this. If I swap the limits of integration, the whole thing is the same but opposite.
Thank you very much.
Thank you. Good. Anything else? Look through and tell me if there is anything else from 5.3. Oh yeah, there is something in 15. It has all sorts of questions or parts. I mean, answers to pick from. So let's do that. So 15. In 15, we have the integral from -1 to 2 from x to -4 dx. And they say it's x to -3 over -3 from -1 to 2, and they calculate it to be -3 over 8. What is wrong with the equation? So whatever they say over there, I don't care. I just would like to calculate this on my own. I don't care about their answer. Couldn't care less. So first of all, I look at this and I rewrite it for a moment. -1 to 2 from 1 over x to the 4th dx. Would you agree with that so far? Is this the same thing with this?
Yes.
Perfect. So now remember, every time we're asked, we can never forget that. Like with limits, we have to plug it in first. We have no choice. The same thing with definite integrals. So when we talk about a definite integral, we have to make sure that this function is continuous on this interval. If it's not continuous, I'm done. I'll say fundamental theorem of calculus part 2 not applicable. I have to wait till calc 2. If it is continuous, then I will go back here because I prefer that versus this. So what do we conclude? Is the function continuous on -1 to 2?
No.
No, because the function does not exist at 0. So I will say FTC part 2 not applicable. I don't care what they came up with. Good. Okay, number 19. We had a couple of problems like number 19, but let's look at 19. So number 19 is y equals the integral from cosine x. We probably did this one. I think we did. Sorry. Natural log of 4 plus 5v dv. We probably did it last time. Do you still want to do it? I don't. We can look at the previous one, number 18, if we did this one. I think we did.
We're here. Let's do it.
Okay. So again, the same thing. Once I have limits of integration that are functions, obviously they can only ask me to find y prime. There is nothing else. A definite integral has to have numbers as limits for me to determine anything here, but these are functions. So is this ready for differentiation? If it's ready for differentiation, I'll differentiate. But if it's not ready for differentiation, then I have to prepare it for that.
No.
It's not. Good. So what do we have to do?
Turn the lower limit into some sort of number.
Correct. And how do I do that? So let me refresh your memory on another property of the definite integral. The integral from 1 to 4 from f of x dx is the same with the integral, for example, from 1 to 2 from f of x dx plus what?
2 to 4.
Very good.
F of x dx.
That's it. So I'm going to use this property here first. So I'm going to write that this is the integral from cosine x to a number plus the integral from that same number to sine x. Natural log 4 plus 5v dv, natural log 4 plus 5v dv. I see two integrals. I'm happy with one of them, but I'm not happy with the other. Which one I'm not happy with?
The sine x?
I am happy with this because it starts with a number and it has a function. I'm happy with this one. I'm not happy with this one because it has a function as the lower limit, not a number.
You need to invert the...
Yes, I swapped the limits of integration. I put minus in front, and now everything is done in the sense that everything is prepared for differentiation. Are we okay with this?
Yes.
Good. So now we can find y prime. Can anyone dictate y prime? Maybe that's what we should do. I should wait for a minute for you to work on this and give me a number. I'm sorry, give me an answer, and then we do it together, or whatever works for you. So what do you think about this? So what do we think? So when I differentiate this, what do I get? I have to copy the minus. And then?
Minus 1. Oh.
Natural log of 4 plus 5
cosine x
times the inner function prime.
minus sine x.
Very good. Don't forget to multiply. I'm not saying you forgot, but please don't forget this is multiplication. It's just a chain rule. Plus what?
Natural log of 4 plus 5 times sine x.
Times?
That's cosine.
That's it. All I have to do, and there is nothing else, I will just multiply these two and get positive and put the sine and cosine in front. Sine in front of this term and cosine in front of this term, of course. So then y prime equals sine x, natural log of 4 plus 5 cosine x, and plus cosine x, natural log of 4 plus 5 sine x. Next problem. Anything else you want to continue with? Do you think there is anything else from 5.3? Don't leave any stone unturned. I want you to have this done sooner rather than later. Is there anything else from 5.3? Or can we say that 5.3 is done? Next week, I would like also to review for the final, not just review for test 4. Anything else from 5.3, or we move on to another section?
Did we do one like number 18 together? I can't remember.
18 from
5.3. Yeah,
yes, it's identical with the one we just did, but if you want, we can.
I'm just confused. I guess I'm. You know what? I'm just confused about like the exponent in the upper limit. Yeah, you know what? Can we just do it just because?
Yes, it doesn't mean anything. You just have to. Yes, let's take a look at it.
Okay.
Is it ready for differentiation? Of course, the same question. If I have functions here, I can only be asked to differentiate. I can never be asked anything else. So, is it ready for differentiation?
No, not yet.
No. So what should I do as the next step?
So you need to apply the same property that you.
Very good. From x to a number, from e to t to the 4th dt, plus from the same number, you can put 0, you can put 10, you can put 100, whatever, if you don't want to put the sign, or put just a, it doesn't matter, to x squared, from e to t to the 4th dt. Is it ready now? And which one is and which one is not?
So the first one still isn't, so it needs to be swapped.
Ah.
Or, yeah.
Now full stop, and now we can differentiate. So can anyone tell us what to write?
So the negative integral that number to x. Oh, so e to the x to the 4th
Times the inner function prime
1
plus.
So e to the x to the 8.
Yes.
Okay.
Times the inner function prime.
2x.
Very good. So this is negative e to x to the 4th plus 2x e to x to the 16th. Copy the base, multiply the exponents.
Thank you.
Thank you. Anything else that you may have run into difficulties with in section 5.3?
For that last part, very trivial, but how did you get to the x? So x to the second to the eighth. Maybe I'm not seeing how I got to that.
So